Welcome to What Is It About the Weather, a podcast where we explore the many ways that weather intertwines itself into our lives. I'm your host, Mark Jelenic. This week, does weather bend or does weather break? Or somewhere in between? In any case, we'll get to that in a bit. Pretty busy out there in the tropics. Last week, I think when I finally recorded, sorry about the lateness again, we were talking about Eta, right? We're in the Greek letter world. And at that point, we're still dealing with, a system that was kind of getting its act together, kind of doing its thing. Yeah, setting kind of record territory, but wasn't necessarily an impressive storm at that point. Of course, that'll change. Came quite a hurricane, made landfall. Now it's back over water again and headed north. This isn't that uncommon for this time of year that we have what I would call these meandering systems. As we go through these transition seasons, as we start to see weather patterns that shift, so we've kind of gone from that summer, early fall cycle of maybe not as many frontal boundaries passing through the mid-latitudes, but as that changes as we move towards wintertime, we also see steering influences change. And that storm, and I'm already was kind of looking at some maps just a little while ago. Looks like it's going to head over Cuba, then head west again, then maybe drift a little bit and head north before maybe next weekend making landfall. But part of it is the strength of a projected frontal boundary, and whether we're going to see it pull, which is, a lot of times what happens is as these mid-latitude weather passes by, it can either open a gap. Sometimes you hear it discussed that way. Sometimes it kind of drags the storm along with it, or in this case, it looks like the frontal boundary may sort of stall, so who knows? Who knows what's going to happen? Actually, out in the Pacific, we had the strongest tropical cyclone of the year. Guni, I think is how it's pronounced. It's a Korean word, if I'm remembering correctly. I don't know how they keep up with that. I have a hard enough time with the Atlantic storm names. But if you ever look at how the Pacific storms are named, you have all these countries that can offer up names. And of course, every country's dialect is different, so the English spelling of all these things doesn't always make sense. So I think I got that right. But even where it made landfall, thankfully, it was in a less populated area of the Philippines, but nonetheless went through kind of right south, I think, of the main island in the Philippines where Manila is, big population center. Nonetheless, still devastating to some croplands. Loss of life seems not as big at this point, but they had a different name for it. I don't know, specifically why they did that. I think it was like Raleigh or something like that. Again, it may just be that it's easier for them to track it that way, knowing it by a name that means something to them. Don't know. Nonetheless, those sort of things going on, but that storm is a reminder that as much as I end up talking about a lot of weather, U.S. kind of is the number one thing, and then sometimes in Europe, just because that's where the news stories flow. A lot of times you don't get it. Part of that's English language sort of thing. So if it's not in English language, it's not going to necessarily hit my news feed or the places that curate news stories for me. So I do every now and then try to make sure I'm branching out and getting it. And that was a reminder of that. This was something that was big, halfway around the world from me, but that happens all the time, and weather takes place all over this globe. All right, let's get back to weather and life, if you will. I want to specifically talk today, I said bend or break, because I want to talk about weather's influence on metal. That's right, you heard me, metal. Iron, steel, copper, aluminum, all these sort of things. And we're all probably very familiar with the idea of weather having an influence on metals. Our most common way to see it is just general oxidation. So when you see we'll talk about rust a little bit more in a minute, but rust color, if you will, on iron or steel, very familiar with that. But you see it in other metals as well. Things like the greenish hue that shows up on copper or brass or any of those sort of alloys, that oxidation takes place that way. It changes the color. Does it seem to ruin the metal? Now, all this process does influence the metal, but even things like gold and platinum that we don't think of as tarnishing, right, from its exposure to air, they all do oxidize, right? Everything oxidizes to some level. Some metals are better at dealing with it than others in terms of, impacts. Jewelry, one of the reasons gold and metal, gold and platinum and things like that are used is because that oxidation takes years and it also has a minimal impact. Another example, though, is aluminum. So aluminum is a metal that, 100 years ago wasn't that prominent of a metal. Now we see it everywhere, particularly with food items and things like that, because we don't think of it as rusting, right? We don't think of it as having a problem, but part of it is the way it oxidizes. It actually creates an outer shell, if you will. So aluminum does oxidize, and that coating sort of protects the rest of the aluminum. So it's kind of a neat metal in that way. But even rust, so to get back to rust, a lot of surfaces you will see, or like maybe exposed steel or things like that, you'll see kind of that outer layer of rust. And they don't worry about that too much because that outer layer actually kind of it does perform in a way that it creates a protective barrier, if you will. So it provides an opportunity for that outer layer to oxidize without undermining the structural integrity of the metal. All right. So I guess it is performing a duty, if you will, of protecting the rest of the metal. But the idea is that with rust, one of the challenges that we run into is if that gets flaked away. So one of the worst things you can do with a rusty surface is kind of flake away some of the initial rust, because then the underneath layer will then likely rust. And over time, that's where you get into problems. People don't think about that often. They don't think about cleaning as being necessarily a bad thing. But I've mentioned before, I lived in an area of the U.S. that gets a lot of snow and road salt and all those things. So between the salt and the water and just the air itself, all that stuff gets up underneath the car and it kind of eats into that surface. Well, our natural instinct is to go and clean the car, right, and get all that stuff off of it. But actually in cleaning it, if you start just breaking away a little of the rust, it makes it prime, if you will, for more rust to form, and eventually will break down the quality of the vehicle. Not necessarily a good thing. But that's kind of, we're all sort of familiar with that. Like I said, we've all seen oxidation of metals probably, and we're all used to dealing with rust and have seen rust impact things that maybe we own in some way. But I wanted to talk about it from a little different standpoint. There were two things. As always, there's things that kind of pop in my head that lead to these topics. One of them was, actually, they both end up being about being outdoors and doing sporting activities. But the first one has to do with a company called Seasucker. Seasucker is a brand of mounts that you can put on your car, for instance, to hold a bike. But that's not where they got their start. As the name implies, they made mounts that are like big industrial suction cups, if you will, to hold things on boats. That's really kind of more of their background, hence the name Seasucker, right? So they're used to marine environments. But they made these really, really strong mounts that you can use that don't require screws or anything to fix something to the surface. They just use a very, very, very strong suction cup. That was one that I saw. And I was reading some stuff about weather influences on those Seasuckers. The other one is a thing that came across my feed this week. So any of you who, we all have our Twitters and Instagrams, or Facebooks, or whatever it is. We get news of right of ways, emails. One of them that I get stuff from time to time, and I'm not alone in that, is LinkedIn. But a lot of times, it's the same old things. It's so-and-so got a new job. So-and-so's looking to hire people. So-and-so updated whatever, has been in a company for so many years. Congratulate them, whatever it might be. This week I got a message that said another, weather-related person is reaching out to you, and they had this to tell you about. So I opened it up because, they always send you those cryptic emails that don't quite give you the full thing. And you have to go into LinkedIn, of course, to look at it. And it was about a Kickstarter. And it was a Kickstarter from a company called Meteo Tracker. It's not a U.S. company. I think it's Italian, if I'm remembering correctly. And the person had sent me a link. And, I'm sure I was one of many people that got it, that talked about a new little mini weather station that they were developing. Okay, immediately you got me. Tech, weather, doesn't take much. You got me sunk into looking at what they're creating. Went in there and started looking at it. And they're creating a little mini weather station. So like a personal weather station. But it's a little different in that it works best if it's on a moving device, car, vehicle, whatever it is. In this case, they've developed a mount that you can put it on, for instance, a bicycle or a motorcycle or something like that. But it's also designed with little feet that have a magnetic ability to attach the car. And they have, in their FAQs, they even talk about that it can handle really strong winds flowing through it, or speed of a car, if you will, and it should stay attached. At least that's what their testing's done. So those were two things that kind of caught my attention, right? Now, your initial instinct may be, well, what do those have to do with metal? Well, they're both attaching to metal, right? And that's kind of where it went there. And I started wondering, because I was reading about the influences. I already know about one. We'll get back to the magnets of that Meteo tracker. The magnets that it uses, if they get really warm, or as magnets get warmer and warmer, they become less effective. And this has to do with how much the individual atoms in the metal move around and the way magnetism works. I'll put a link in the show notes so you can read a little bit about that. But in theory, I was kind of wondering if the car got too hot, would that influence the potential for that thing to come dislodged? Now, in reading a little bit more about it, because I did do some reading about that, I think realistically the metal would have to get really hot. But maybe if in certain climates, if you were in a situation, it could get to where the metal was so hot. But then again, if it's sitting on top of the metal, that would keep some of the direct sunlight off the metal. So maybe it wouldn't be too much of a problem. And the other, again, on the Sea Sucker, is kind of the opposite thing, which is they advise you that if under certain weather conditions, the sucker may lose some of its strength, and it's something you need to monitor. More likely, though, that has to do with how the suction cup, so the material in the suction cup, the rubber plastic combo, I'm not sure what the breakdown is on that. And we've all seen this. Anybody who's used a suction cup before knows that maybe if the metal gets too cold, it's not so much the metal, but how elastic that suction cup becomes. It starts to lose its grip a little bit and can let go. So that got me to the topic, but it really didn't. Neither one of those cases was it the individual metal itself that was likely going to create a problem. But I was curious about how metal changes. Do we really see a difference with temperature? So I wasn't thinking so much, like I said, about rust. I started wondering how much metal is influenced by different weather conditions in ways that could be detrimental. Because I've read about before, but hadn't really thought about it in a while. So let's talk about cold. So when metals get cold, and I'm really breaking down here to things we use in construction. So generally, let's narrow it down to steel for a minute, just out of simplicity. But it could be any sort of alloy or something that you're going to use in a very strong situation. And as metals get colder, you start to see something about its brittleness, right? So it goes, they even call it the ductile to brittle transition. And this has to do with basically whether a metal will give a little bit when you hit into it. And think about it this way. When you get into an accident with another car and you've got metal bumpers, is that metal going to bend, right? Are you going to get a dent, or is it going to snap? And I even read an article that talked about one of the problems with the Titanic when it sunk and when it hit the iceberg. It was really cold waters. It was very cold. And under normal circumstances, a iceberg could have hit the side of the ship and just caused the whole piece of metal to bend. But as it gets really cold, if it's not the right kind of, it's not, made with the proper alloys to make sure it maintains a sort of bend to it, it becomes brittle, and therefore it snaps. And maybe you've seen this in metal, but in colder climates, and I can even think about around here, I read another article, if I just go north into Canada, right, where they have to do a lot of construction, maybe in cold seasons, and they talked about how heavy machinery, anytime you're doing something that creates a lot of pressure or tension, things tend to bend or give a little bit or deform a little bit. Now, we may not see it, right? It may be that small of a difference, but under certain circumstances, if it's not designed to bend and give a little bit and then bounce back when the pressure is released, instead it snaps, then it's not any good. And this is something that's real for steel, right? So you have this ability when it gets really cold, it will become more brittle. And therefore, if you're working with metals in those environments, and that, like I said, it was even talking about machinery, not construction materials itself, how you had to watch the type of loads you might put on your machinery because it's not going to be able to respond the same way. Right? And you have the potential, if it's not built with a certain alloy, and there are things we can do, and that's one of the benefits we have as we learn about these things. You can make the alloy of the steel different to be better able to deal with cold weather situations. But if not, it becomes brittle and can crack, right? Now, the flip side of that is what happens when it gets hot. And as metal gets warm, it expands. And in things that have a very tight space, that can cause a real problem. There's examples of drawbridges, you don't think about them much, but they're big metals that use these joints and they rotate on those joints, but there's not necessarily a lot of room to give. And metal doesn't expand all that much. I mean, we're talking about fractions of a percent, but in very tight situations, that can be just enough. And there was a story, and like I said, a lot of this stuff I've put links to in the show notes, about a drawbridge that they literally had to call out the fire department because it was a day when it was over 100 degrees Fahrenheit in the city, and the bridge had gotten so hot. Metal's such a good conductor of heat, right? All this heat going into the metal that the joints had expanded, and the bridge couldn't open, so they literally had to put fire hose water on there to cool it off to be able to open the bridge. And you've probably seen other examples of this potentially. Another classic that I've seen is, probably first saw it sometime 10, 20 years ago, was an example of it was so hot that railroad tracks buckled. Now, as I was before I was talking about how metal got to being brittle and would snap. So on the other side of that, it can get to where it deforms. Now, it is important to recognize that under normal situations, if a straight piece of track is just laying there and it gets hot and it cools back down, it's not going to just magically bend. When it bends, it's again because it's under pressure. So it's actually this combination of pressure and not necessarily atmospheric pressure. I'd love to blame it all on the weather, but it's not that simple. But let's say two pieces of track have been connected or are put together in such a way that they need to have a high tension for safety. Maybe it's a high-speed train or some other design. And again, not being the engineer here, I don't know all the details, but the higher the pressure, right, that metal is under, when that heat causes this deformation, if it doesn't have some way to go, it deforms. It can deform in a major way, right? And railroad tracks is an example of that. But that's why you don't necessarily see miles and miles and miles and miles of deformation. You might have just seen one section that was under a particular amount of torque or tension, or in an environment, maybe it was on a natural bend to begin with, where it had some bend already in it, but the pressure when it finally got too hot, and this not necessarily just weather does this, if it is a high-speed train or a train track that's used quite a bit, and so there's a lot of frequency of heat that gets built up because maybe it is a warm season and the track's used again and again, and the heat transfer from the friction, et cetera, that's from those trains going over it can cause that deformation as well. But it's the pressure in that situation. And we sometimes forget that when heat is applied, when we make things out of metal, right, they tend to hold their shape. And springs are a classic example of that. That's why springs, you can, I've got a little spring on the setup here. Let's see if I can get it to make a little noise. Maybe that carried through to the microphone there. Hopefully that did. But it's the arm that holds the microphone that I'm speaking into. And over time, for the most part, that spring will hold shape and hold a certain tension to it. But if I heated up that spring while I was applying tension, it might finally release. And this all has to do with how the metal was molded and everything else that makes metal hold to a shape. But once it cools, it wants to hold that shape indefinitely, right? Thankfully, and I did read about this, the temperatures that we see normally on the planet aren't going to be hot enough to just deform a spring. Now, springs have other issues over time if they're kept in a certain position or not used. or use too much, or if you pull them too far apart, they eventually lose that spring. And I think of spiral notebooks as being a classic example of that. If you've ever tried to unwind a spiral notebook, you get to some point where it holds that spiral, but if you finally pull it enough, it will release, right? It reaches the point where it doesn't have that response. Metals are the same, just in everyday heat. So it's going to expand, and normally it's going to come back, but under the right circumstances, it can be in a heat process enough to finally bend it, or in a cold process enough to finally break it. Now, most of these things we don't run into every day, right? But there are examples of where it can be real for us. And I'm somebody who has some metal stitches in one of my feet, right, from surgery I had done a long time ago. And every so often, when the weather changes, or particularly it's cold outside, my foot's cold, I notice that foot feels a little different. And this is a real world example of metal, right, influencing our lives. There's a lot of people out there that have metal in joint replacement surgeries. And what we have is when it gets particularly cold. So when you think about the human body, 98.6 Fahrenheit, we deal with this range. Our body runs pretty warm. And we have a natural temperature that we kind of like, and it varies by person, but somewhere, in the, let's say 25 C, 75 Fahrenheit, in that range that we all have, it's kind of a comfortable range to us. But that's already colder. So even at that temperature, we have a unique thing that goes on with metal. Metal's very good at conducting electricity, example, but also as a thermal conductor. Much better than tissue. And this also has to do a lot with how much airspace there is. Okay? So metal conducts heat extremely well. And so when it's cold, so our body, we don't generally get to temperatures that are above our body temperature. We don't all live in them. Yeah, there are exceptions to that. And so there's a situation where if it got really, really warm, we would probably feel it in the opposite direction, where a joint might feel almost like it's burning because it's conducting that heat. But generally speaking, when it gets cold outside, what happens is the thermal conductivity of metal makes it feel different. I mean, I think that's the biggest thing to recognize. It doesn't take the heat away from our body at the same rate, or that joint, that metal piece of metal in your body doesn't respond the same as the tissue, even the bones, whatever it is in your body. So heat transfers differently, and so it can make you feel uncomfortable, or the pain receptors may respond in a different way. And so, like I said, every so often when my feet are really cold, particularly when they first get cold, I feel it in that one foot more often than other things. So that's an example of, even within our body, how the metal changes can cause that to behave differently, right? So we do. Metal temperatures, like I said, there was different things that brought me there, but when I started going full circle, every day we can see things in the different seasons where these things that we think of as being so solid and so strong and everything else get to thresholds. We all have thresholds. They have it. And in the real world, temperature changes can cause impacts for something as simple as metal. Now, I will remind you, if any of you have ever seen A Christmas Story, the movie, and know there's a classic scene in there where the kid is double dog dared, I think, or triple dog dared, I don't remember which one finally happened, to stick his tongue on the pole. And people often wonder if that's true. Well, it is true that your tongue, if you go and stick it on a frozen pole or a frozen piece of metal, will stick to it. And maybe you've noticed this before, even with like an ice cube, right, that it'll get stuck to your tongue. Well, what's happening there is even that piece of ice is a better conductor of temperature. But more or less, when you stick a tongue on a metal pole, it's the water that's the challenge. This is why it doesn't necessarily just happen with your hand. It can, like I said, if you grab an ice cube and you've got a little bit of moisture in your hand, it freezes right away. So that thermal change between the hot and the cold surfaces at that transaction point will cause the freezing, and that's why the tongue gets stuck. And a real simple way to solve the problem is put some nice warm water, not boiling, but warm enough to warm up the metal just a little bit. Because what your tongue's trying to do is your body will send increased blood flow and everything else to try to warm it, right? Because it's cold. But that the temperature of the pole is so quickly, it's so much better, so much more efficient at dealing with the temperature. It's just stealing all that warmth before your tongue can get unstuck. So just keep in mind, don't stick your tongue to a cold surface, particularly if it's wet. All right. I did mention at the beginning of the show this Meteo tracker. I'm going to put a link in the show notes to Kickstarter about this. I will probably buy one. You guys know me. This kind of weather tech stuff always interests me. But if you're interested in that sort of thing, take a look. I know, a lot of my audience are kind of weathery folks that really like this stuff. Some of you could care less, but if it's a topic that interests you, like I said, what I found interesting about it, the idea is about a weather station that works well in movement. It's not really designed to be, the designs have to be very different for weather stations to be effective when they sit still, right? And they even talk about this some in their FAQs, which is the science behind what they've done and the correction process that they're doing to make it an accurate device is very geared towards a device that's in movement. So we'll see how it goes. But again, it's called Meteo Tracker. Link will be in the show notes. Take a look. But for now, and until next time, when you're thinking about that nice piece of metal, or you ever know, take a metal cup, and this is a great way I know to do it. Do it safely though. And fill it with some warm water, not so hot that it's boiling, but put your hands to it and then do the same thing with like a ceramic cup, same temperature water, and notice the difference about how quickly the metal feels warm compared to the ceramic. And just imagine in the real world how that plays out, right? And just know that we all have thresholds. Just like everything else in life, we have those breaking points, if you will, or bending points. And enjoy what you learn in that. Because as we all know, there's much more weather than the weather itself.